Hey everybody, this lesson is we're going to solve area equations. So we know the area of a rectangle is base times height, the parallelogram base times height. Let's see, what else did we do? We did triangles, 1/2 base times height. We did trapezoids, which is 1/2 the height times the sum of the two bases. Did we do anything? Oh, we did rhombuses, rhombi. So that was 1/2 diagonal 1 times diagonal 2. So here we're just going to use those equations to solve some, equations here, solve some problems here. So how do we use the equations to solve problems about all those figures that we just spoke about? Okay, let's go ahead and get started here. So recall the formula for the area of a triangle is 1/2 base times height. We can also use this formula to find the missing dimensions if the area is known and one of the sides is known, one of the dimensions is known. So here we go. So after winning the state tournament, the wrestling team hangs a pennant shaped like a triangle on the gym wall. The base of the triangle is 1.5 feet long. It has an area of 2.25 square feet. What is the height of the triangle? Excuse me. Well, I've had this cough for a month. Sorry about that. So anyway, area equals 1/2 base times height, and so we just plug in the stuff, and it looks like we're solving for the height right there, okay? So we know the whole area is 2.25, that's what it says right here, and it says the base is 1.5, so area equals 1/2 the base, which is 1.5 times the height. Okay, all right, so there's a couple of ways to go from here, you guys. If you were in my class, I'd get rid of this half. I don't like fractions with decimals, so to get rid of a half, we just multiply both sides by 2. Okay, and that'll get rid of the half right there. So 2 times 2.25 is going to get us 4.5, and then we just divide both sides by the 1.5, and I know 1.5 times 2 is 3, so if we get so if we add another 1.5, that'll get us that 4.5. So I don't know if you understood what I just said, but anyways, 4.5 divided by 1.5 is going to be 3 right there. So the height of that triangle is going to be 3 feet. Okay, now the dimensions are always in units right here. So this is 1.5 feet. This is 3 feet right here. And the area is always in square units. Okay, so if it doesn't say area, if we're looking for what's the height, that's just going to be in just units. Okay, so how come we use, that just be use, USE, units in the formula to confirm that the units for the height are in feet? So sorry about my misspelling. I can't correct that right now. So the square feet in the numerator for the numerator of the area of it divided by the feet in the denominator for the base, and you're thinking, what does that make sense? Okay, so right here, the square feet in the numerator right here divided by the feet in the denominator. Okay, so what happens is this 1 foot right here takes off one of these two. There's 2 feet in square feet. Okay, there's feet times feet, so square feet. I don't know if that makes sense. So one of these feet are going to take off one of these units right here, and so we're going to get 3 feet right there. Okay. And don't worry about that if that doesn't make sense, you guys. I'm sure you'll be okay with your teacher. So, okay, so we can do the same for using formulas for problem solving with trapezoids. Okay, so here we go. So a garden is in the shape of a trapezoid and has an area of 44.4 square meters. Okay, so they're giving us the bases, 4.3 meters and 10.5 meters. And the height of the trapezoid is the same as the width. So how wide is the garden? Okay. So our area formula is that right there. So the height is the same as the width. So we're looking for the height right here. Okay, so whatever the height is, that's going to be our width. Okay, let's put everything in. So 44.4 square meters is going to go for the area right here. 1/2. We don't know that, but we do know the bases are 4.3 and 10.5. So let's plug that in. Okay, order of operations says we have to add these parentheses first. So let's go ahead and add 4.3 and 10.5 is going to get us 14.8 right there. Okay, and then what I'm going to do now is multiply both sides. Or no, I'm sorry. I thought I was going to multiply both sides by 2. But since 14.8 is an even number, we can take half of 14.8. So sorry about that. I was going to multiply it by 2 and get rid of the fraction. But this is cool too. So 2 goes into 14 7 times, into 8 4 times, so 7.4. And then we're going to now take both sides and divide it by 7.4, okay? All right, so I'm thinking, well, 7 times 6 is 42, so probably times 6, I'm thinking. So if we picked up our handy-dandy calculator, if you can't use it, then you can just guesstimate, you guys. So because I know 7 times 6 is 42, so 7.4 times 6 is going to be 7 plus 0.4. Times 6. Remember that trick I was telling you? So anyways, you end up getting 6. I don't know if that made sense. Anyway, so the answer is going to be, the garden is going to be 6 meters wide. Okay, easy enough. Okay, so explain why the first step after substituting is addition. Okay, well, remember the order of operations says we have to do parentheses first on that, so that's why we had to go ahead and add those two pieces together. So we can write and solve equations that represent real-world problems that relate to other relationships in geometry. So John and Mary are using rolls of fabric to make a rectangular stage. So rectangular means base times height when we're talking about area. So curtain for their class, the rectangular piece of fabric on each roll measures 2.5 times 15, so the area is going to be 2.5 times 15. Okay, if the area of the curtain, the whole curtain, is 200 square meters, what's the least number of rolls that they need? Okay, well, first we got to find, let's just go ahead and, what our book is suggesting, rewrite the question as a statement. So find the least number of rolls of fabric that are needed to cover an area of 200 square feet. Okay, now let's list the important facts about this. So each roll of fabric is 2.5 feet by 14 feet, and it's in a rectangle. And then the area of the curtain is 200 square feet. Okay, let me slide that up. All right, so write an equation for the area of each roll. So it's a rectangle, so the area of each roll is going to be length times width right here. So we're going to do 2.5 times 15, or 15 times 2.5. So 15 times 2 is 30. 15 times 0.5 is half of 15, or 7.5. So 30 plus 7.5 is 37.5. Anyways, so that's what one roll is. Okay, so we want to know how many rolls we're going to need to get to that 200. So write an equation to find the number of rolls needed, and we'll let n equal the number of rolls needed. Well, if each roll is this much right here, okay, and we need this much, so what we're going to do is divide this number into this number. So if n is our number of rolls, we're going to say n equals this divided by this right here, okay? Okay, so when we do that, I'm going to show you how they're getting a fraction right here. I put it as a fraction right there so that we can get our mixed number, okay? All right, so we don't like, I'm just showing you, if you have calculators, that's okay too. If your teachers suggest that. If they don't, that's okay too. Don't give up on yourself. So 200 over 37.5, to get rid of that decimal, I'm going to multiply it by 10 over 10, and that's just going to move the decimal to the right one place. So 200 times 10 is 2,000, and then divide it over 375, and then I'm going to start playing the reduction game. So I know 25 goes into both of those, so if I divide both of those by 25, I get that, and I know 5 goes into both of those. So when I divide that by 5, I get that. And then here, now I can get 3 goes into 16 5 times with 1 left over, so 5 1/3. Okay, so that's how many rolls we need. We need 5 1/3 rolls. So if you went to the store and said, I need 5 1/3 rolls, what are they going to do? They're going to sell you 6 rolls. They're not going to sell you 5 rolls, and they're not going to sell you 5 1/3 rolls. They're going to need to get you 6 rolls on that. Okay, let's try one more of those. So a parallelogram-shaped field in the park needs a sod. Sod is grass. So the parallelogram has a base of 21.5 meters and a height of 18 meters. So the sod is sold in pallets of 50 square meters. So how many of the 50 square meters are we going to need to fill up that park? Okay, so what we're going to first do is find the area of the whole park. So we're going to multiply base times height. That's our area formula for parallelogram is. So when we multiply those, I did that trick again, you guys. So 21.5 is the same as 20 plus 1 plus 0.5. And then so 18 times 2 is 36. So 18 times 20 is 360 plus 18 when I distribute plus 9. Okay, so I'm just doing that trick right there, and I get 387 square feet is what the park is going to need. Okay, or square meters. I'm sorry, it should be meters. Oops, sorry, meters. I'd normally change that, but and then start the video over. But we're so close to being done. I hate to see doing that. Anyway, so now we're going to do the 387 divided by the 50, because each pallet is 50 square meters. So how many pallets are we going to need? Okay, so we get 7.74. So that's going to get us about 8 pallets right there. Okay, you guys. And so good old Scooby-Doo needs that saw to take their dogs for walks. And we take our dogs for walks every night. I hope you guys are doing great. Take care.